Here we go. Begin at A. Roll a 6-sided die. I want to be the blue car. I'll be the blue car. And you'll be the yellow car. Okay, so I'm blue, you're yellow. And here goes. I'm rolling for myself first. Here's the rules, and you read them right there. So I'm just going to roll and see what happens. So I get a 6. If you roll a 6, you go back to A. Actually, I'm already at A, so I stay at A. All right, now it's your turn. You're the yellow car. So here's yellow car 1. If you roll an odd number, move forward 1 square. There you go. You're winning so far. We're at the end of 1 turn, and you are beating me. So here goes. Let's keep rolling. My turn again. I'm the blue car. I'm rolling. I get a 4. If you roll a 2 or a 4, move forward 2 squares. Ha-ha. So long, sucker. Take that. All right, your turn. You're the yellow car. We roll. It's a 4. Oh, no. Ah! All right, so vroom, vroom. You're leaving me behind. My turn. 3. If you roll an odd number, move forward 1 square. Vroom. There we go. Your turn. Odd number. It was a 3. You roll an odd number, move forward 1 square. You win. Now, I do want to point out that you have to win exactly. Like if you would have been here and you rolled enough to go forward 2 squares, you couldn't have moved. You'd have stayed there. That's important to know, okay? But you just won, and that is the end of our first game. Let's do this. Let's draw a vertex edge graph. There are 5 different places you can be, A, B, C, D, or E. I've done this problem before, and I put them in a row, and I had arrows going everywhere, and it was a nasty, nasty mess. So I'm not going to put arrows everywhere. I'm going to put them everywhere, but I'm going to put them kind of in a circle, even though that's not the layout of our racetrack that you just beat me on. Way to go. D, E. Okay. And we are going to just go from place to place. So here goes. Let's start at A. I'm gonna be the orange car now, just as an example. This is really tricky. Okay, we have to really be cautious. So we have a sample space. Oh, there goes that phrase again. And here's our sample space: 1, 2, 3, 4, 5, 6. Nobody is surprised at that. But we have different things that can happen. So we can roll an odd. If we roll an odd, that's a 1, 3, or 5, duh. That would be a 3 out of 6 chance. That's a 1/2. We could roll a 2 or 4, and that's a 2 out of 6 chance. That reduces to be 1/3. Or we could roll a 6, and if we roll a 6, that's a 1 out of 6 chance. Okay, I'm saying this here because it's going to come in handy as we continue to build this thing. So, draw a vertex edge graph. Let's start at A. The probability that I stay at A, if I'm going to stay at A, then I have rolled a 6. At the beginning of this game, that's exactly what I did. I rolled a 6 and I stay at A. So let's use the green pen just for fun. So starting at A and remaining at A, there's a 1 out of 6 chance that's going to happen. Okay. Starting at A and moving on to B. Okay, that means I'm moving forward 1 square. All right. If I'm going to move forward 1 square, I rolled an odd number, and odd numbers, there's a 1/2 chance of that happening. So moving from A to B is a 1/2 chance. Okay, I want to know how I can get to C. Well, if I'm going to go from A to C, I'm moving forward 2 squares. Moving forward 2 squares means that I rolled a 2 or a 4. There's a 1/3 chance of that. Okay, now this graph, this is called a graph, vertex edge graph. It's going to get really cluttered really fast, okay? We're going to have a lot of numbers, and they're going to be all over the place, and it's going to be nasty. So I'm not going to draw the zeros. I'm not going to do that. And by the way, I told you on a previous problem that all these better add up to 100%, and they do. 1/6 plus 1/2 plus 1/3 is 100%. Okay, let's start at B. The probability that I go from B back to A means that I rolled a 6. There's a 1 out of 6 chance that happens. We're switching colors. Things are really going to run together if I'm not careful. So going from B back to A is a 1 out of 6 chance. The probability that I stay on B, I'll never stay on B. Nowhere in here do you see directions that say you stay where you are. Well, I'm not staying where I am, okay? If I want to move forward to C, then I've moved forward 1 square. That means it was an odd number. That's a 1/2. If I want to move forward to D, I moved forward 2 squares. It means I rolled a 2 or a 4, so there's a 1/3 chance of that. Let's swing this around. This is going to get really cluttered, I'm telling you. 1/3. All right. Let's start at C now. By the way, 1/6 plus 1/2 plus 1/3. There you go. If I am at C, I have a chance that I could go back to A. Switch colors again, going purple. If I'm at C, I could go back to A. And that happens if I roll a 6. There's a 1 out of 6 chance that happens. I will never move back 1. Nowhere in the directions do you see move back 1 square. Nowhere in the directions do you see stay where you are, unless you're on A. So I'm not going to ever go back here. I'm not going to stay on C. I could go forward 1 though. If I move forward 1 square, I rolled an odd number. That means it's a 1/2 chance. So 1/2. And if I'm on C, I could move forward to E. If I move forward 2, that means I rolled a 2 or a 4. So moving from C to E, which means I win, there's a 1/3 chance of that happening. See? Okay, we have taken care of what happens at A, at B, at C. Let's go to D. Let's suppose I'm sitting here at D. I'm switching colors again. If I'm sitting here at D, the probability that I go to A, I can do it if I roll a 6. So I could go from D all the way back to A, and there's a 1 out of 6 chance that'll happen. Okay? If I'm sitting at D, I'll never move back 2. So D to B is not a thing. If I'm sitting at D, I'll never move back 1. That's not going to happen. If I'm sitting at D, I actually could stay at D. And this is the tricky part. I can stay at D if I'm sitting here and I roll a 2 or a 4. And then it says move forward 2 squares. I can't move forward 2 squares. And it's based on this. You must roll an exact number to win. So I can't move forward 2 squares, so I stay where I am. So if I roll a 2 or a 4, I'm stuck if I'm at D. And there's a 1/3 chance of that happening. Okay? And then if I'm going from D to E, well, I could move forward 1 square. Moving forward 1 square is an odd number, and there's a 1/2 chance of that. I told you this one's nasty. All right, let's suppose I'm sitting at E. What's the probability that I stay at E? Well, you're done. You win. Once you get to E, you win. So I do need some numbers here. Well, I don't need all the numbers. I'm not ever going to go from E back to A. Like, you're done. You don't roll anymore. But you will go from E to itself in a sense. And there's a 100% chance of that. Once you win, you won. Like, there's a 100% chance you stay there. You're done. All right. Now let's write the adjacency matrix. It's going to be fun. We're going to call it A. So, well, capital A, not to be confused with this A, all right? So I'm not actually going to write A equals, because I'm also going to have A, B, C, D, E, and then A, B, C, D, E. Leave yourself some room. We're going to have a lot of numbers in here. All right, here we go. Let's start from A. To A is 1/6. From A to B is 1/2. From A to C is 1/3. A to D is not a thing. A to E is not a thing. You can't win in one turn. All right, from B to A is 1/6. From B to itself, B to B, that's not going to happen. From B to C is 1/2. From B, sorry, bumped the camera. B to D is 1/3. and B to E, it's not a thing. You can't win starting on B in one turn. All right, let's start at C. If I'm at C, I could go to A. That's a 1 out of 6 chance. If I'm at C, I can't go to B. If I'm at C, I can't stay at C. If I'm at C, I could go to D. If I'm at C, I could go to E. All right, let's start at E. Sorry, let's start at D. I'm losing track of things here. Let's get a pencil and make things a little bit clearer. There we go. And that complicates things. All right, let's start at D. I start at D, go back to A. I could, 1/6 of a chance. If I'm at D, I won't go to B. If I'm at D, I won't go to C. If I'm at D, I could stay at D. If I'm at D, I could go to E. By the way, every row should add up to be 1, and they do. All right, E's the easy one. If you're at E, you don't go to A, B, C, or D, but you stay on E. All right, let's finish this problem up. Here we go. I have typed it into my calculator. Again, you can use desmos.com/matrix. We're going to square this. And when we square this matrix, that tells us, again, noticing that we're squaring it to the second power, that's going to tell us the probability, excuse me, of winning or getting, not winning, but getting to a specific place within 2 turns. So we have all this. I'm going to actually turn these into fractions because I feel like it. And notice that they did not say what is the percent. They said what is the probability. So I think we can go with fractions in this case. So let's write it down. Here we go. A squared equals... Now, again, don't confuse this A with that A. That's a location. This is a matrix. And that is equal to A, B, C, D, E. And then A, B, C, D, E. We're going to have lots of fractions in here. It's going to get kind of gross. 1/6, 1/12, 11 over 36, 1/3, and 1/9. 1/6, 1/12. 1/18, 13 over 36, 1/3. 1/9, running out of room here. 1/12, 1/18, 1/6, 7 over 12, 1 over 12, 1 over 12, 1 over 18, 1 over 9, 2 over 3, 0, 0, 0, 0, 1. Okay, so here's what it means. At the beginning of these 2 turns, if you start at any of these specific places, these are the probabilities that you land up here. So like, let's suppose at the beginning of those 2 turns, you started at A, the probability that you're on E is 1 out of 9, which would be really rare. So you could win within 2 turns. I was mistaken. I think earlier I said you could not. But if you started at C at the beginning of these 2 turns, apparently we're starting in the middle of the game, then the probability that you're on E is 7 out of 12, 2 turns later. Okay? Probability that you win the game in 2 turns. Now, as we talk about this, we are talking about starting on A. So really, all this matrix is great and fantastic, but this is what we really care about because this is where the game really does start. It starts on A. So since we're asking those questions, let's answer them down here. Probability that you win the game in 2 turns. Well, if I am going to win in 2 turns, I start at A, I end at E, that would be 1 out of 9. Again, they didn't say percent. They said probability, which could be a percent, could be a fraction. Within my context of thinking, I think it's a fraction. Probability that you end on C in 2 turns, that would be 11 out of 36. 11 out of 36. Probability that you end on B in 2 turns, that's 1 out of 12. Probability that you end on A, 1/6. There you go. That's it.